Okay, good morning. Let me start by just translating Ralph's introduction for you. I'm not an engineer. I translate what engineers do into English. And I've also tried to follow Ralph's good example in not wearing a tie. I worked for an AA a number of years ago who thought the last thing people in an R&D organization should do is cut off the circulation of their brains. And so if you don't want to wear a tie today or tomorrow, just get rid of it. So I wanted to try and provide again a little bit bigger perspective from HEO management about what we're doing and why we're doing it. And then from there, I think the agenda that you folks have laid out for this session is really great. I think you've hit really timely topics, you've hit important topics, and I'm looking forward to hear what comes out of this. So how many of you have not seen this chart before? Anybody not seen this image before? Okay, good. I have a love-hate relationship with this chart. It's artistic, and so it's a little bit right-brained for me, but it does make a couple of important points. One is that this requires science and technology and exploration to work together. So this is a cross-directorate endeavor that we are embarked on in exploration. And so those communities, there have been times when there have been firewalls, literally, between those communities within NASA, and we're still challenged to break those down and get them all to work together. The other important part of this is the line across the bottom, because it really conveys the strategy for exploration. We're starting in an Earth-reliant frame in low Earth orbit aboard the International Space Station, where missions are measured in 6 months to a year, and return times are measured in hours. That's a great place to start. It's a great place to learn about HEOMD Spaceflight, and you're going to get to hear from Kjell Holmgren tomorrow about some lessons learned from his time on space station. And then at the other end is this Earth-independent frame where we're outside the Earth-Moon system and even at Mars, where missions are 2 to 3 months in duration and return times are measured in months to a year. That's an entirely different operational regime, requires an entirely different approach to how we think about systems design and system operations. And so we have the good fortune to have this middle section that we call a proving ground, taking advantage of this handy large natural satellite we have called the Moon, in which missions can be measured in days to a couple of weeks, and return times are measured in days to a week. And there we have a practice arena, an ideal practice arena for the kind of systems we need to build to pursue exploration to the Mars system. And so the decade of the 20s is really going to be the decade of the proving ground, of operating in cislunar space. That's going to be a challenge for us as itself a new operational regime, but also a great place, a safe place, relatively speaking, to practice deep space operations. So that's the grand strategy we're pursuing. The other reason why I like this chart is it's great to make fun of, right? So why are we going to explore Mars, right? If you're familiar with planetary science, you know that Mars lost its planetary atmosphere as much as 1 billion or 2 billion years ago. And so having lost theirs, they're not going to steal that of Earth, and they must be stopped. So this is why we're going to, you can see there's lots of things you can do with this chart to make it entertaining for you. So how many of you have seen this chart? Did I skip one? Oh, okay. That one's kind of boring. We'll go back to this one. Okay, what am I doing here, guys? There we go. Okay, how many of you have seen this chart before? Okay, all right, so maybe a third of you have. This tries to break the plan down in a little more tractable phases. It starts in the upper left with what we call phase 0, where we are now in Earth-reliant exploration. We're testing systems on ISS. We have ISS available to us now, to at least 2024, maybe a little beyond that. We want to be able to test the Mars-class Eagles system on ISS before we use it in cislunar space or beyond. And so we have this great platform for human exploration operations available to us. We need to make the full use out of it while we have it to test not just the human research program activities, but also the technologies and systems we want to use in deep space. Then the proving ground phase is sort of divided up into a phase 1 and phase 2. We want to be able, in cislunar space, to be able to test exploration systems and be able to deploy an initial habitat capability, be able to do the kind of one-year increment missions we did in now the cislunar environment. And then we want to be able to get to the point where, with this asteroid redirect crewed mission, that we are doing autonomous rendezvous and docking. We're doing EVA in deep space. We're doing the kinds of things we're going to need to learn to do in those distant operational regimes. And then phase 2 is where we're now moving from testing those systems and practicing those to really validating them, such that by the end of the 20s, we want to have validated the readiness of our crewed systems to leave the Earth-Moon system and do beyond Earth-Moon system exploration and eventually on to Mars. And so validation is the key word, marking the end of that proving ground phase when we've graduated out of that, such that we know that we can safely explore in those more distant regimes. And then phase 3 and 4 are essentially operating beyond the Earth-Moon system and conducting the preparatory missions required to be at Mars, pre and placing resources and assets in Mars orbit and even on the Martian surface, and such that in the late 2030s, even 2040s, we'll be doing Mars landed missions. And so the point is we're trying to break down the problem to the next level. And then if you have been following the Human Exploration Director Management Council activity, you'll see that under Jim Freeh's leadership, we've baselined a set of objectives for phase 0, 1, and 2, that we can then move from that set of objectives to defining a set of flight test objectives that we can then turn around and allocate to EM2, EM3, EM4, and beyond. That's the stage we're in now. So that's the progress we're making in terms of laying out a strategy for getting from here to eventually to Mars. So we're making some progress. In fact, we're making some great progress. Ralph alluded to earlier all that programs that are in development now, and we're moving out smartly on all of those. Orion, EM1, that vehicle we're going to use for EM1 is, of course, in the ONC at KSC, and that assembly is going well. Lots of work going on with SLS core stage and engines and boosters, and I had a conversation earlier with Preston about the manufacturability of the RS-25, doing a lot of work there to allow that engine to be reproduced, since we're not going to be able to reuse those the way we did in shuttle in this environment. GSDO, lots of stuff going on. I love the GSDO guys. They have this practice they do called Good News Friday, and they essentially publish a summary of all the work that's been accomplished that week. And I read the one that came out on Monday. They had a special Monday edition, and it was amazing to see in the VAB and in the umbilical work and the flame trench and the mobile launcher, all of the work that's actually going on. This is real. This is really happening, and it's encouraging to see. And I'd encourage all the programs that to follow that example, to put out a status that is visually oriented, so people actually see around the agency the progress we're actually making. Commercial crew, a lot of great progress there. Work that Boeing's done on their mass reduction effort, and SpaceX completing a Delta CDR. Lots of challenges ahead for those programs, but they're making great progress. ISS delivered the International Docking Adapter, and we returned the samples from the one-year crewed mission, and those are now in work. And I'm told that early in the new year we'll begin to see scientific results, papers published based on the analysis of those data. That'll be great. Asteroid redirect mission, good stuff going on. They accomplished their KDP-B. In fact, what week is this? Last week, they had their very first quarterly review. Significant milestone for them internally as a project and program, being able to get their team together and assess where they are. SCAN successfully supported the Juno mission. They've installed, if you may be aware, SCAN is in this process of, we've had these 70-meter dishes at the 3 DSN sites around the world. Magnificent antenna that still do great stuff. We rely on them. But they're really expensive to maintain, and so they're going to a strategy to move those to arrays of 34-meter dishes. And so that installation work is ongoing. They just installed the second one in Canberra and initiated installation of 2 more in Spain. The Launch Services Program launched OSIRIS-REx. That's a great program. It's one of the best little managed programs in the agency. It's pretty impressive, the work that they do, not just for launching those missions, but serving as advisors on challenges we have, for example, in the commercial cargo program. That resource has been invaluable. And then AES, selection of the next step phase 2 awards. This is the activity that we're doing to begin to define habitation in cislunar space and understand the challenges with that, and maybe some innovative ways to go about that. I put that one down there, and Chris Moore is here, and if you get a chance, ask Chris about the other stuff that AES is doing, because they've got a family of technologies, not just technologies, but systems, flight systems that they are maturing and making great progress on. So that just, again, wanted to give you a broad sweep of the directorate and what's happening around the set of programs that are underway. And then wanted to now, of course, kind of follow up with some challenges. This is not, whoops, boy, this thing is tough to, very sensitive. Okay, exploration systems development. We're working through the ESA service module delivery schedule. And we brought ESA into the critical path of the Orion program, or of our exploration program, because it was important for us to be able to move forward internationally. Because when you take the longer view, as Gerst has, about actually getting to do deep space exploration and onto Mars, it really needs to be an international endeavor. And so he chose to bite the bullet and incur the challenges associated with having an international partner in your critical path, and said, hey, ESA, we'd like you to develop the service module. And that's going, technically it's going pretty well. They've had some schedule problems and some technical problems, but they just completed their Delta CDR and made some great progress with that. So they're pressing on, but still a significant schedule issue there. We're getting to EM1 on time. SLS LOX tank weld strength. That's actually a challenge, but it's also kind of a good news story. It talks about how we are flexible and how you guys are making stuff happen in this program. We've got this weld schedule in the big vertical assembly tool at MAF, and ran into a problem with the LOX tank and the weld strength, because the LOX tank is thicker than the others. And so while they're now taking that offline and trying to figure that problem out, they're redoing the weld schedule and bringing other pieces in that can be done. And so this is the kind of stuff that has to happen in order to maintain an efficient development program. And so the team is doing well, not just in trying to understand that problem, but not letting that problem hold up progress on the rest of what can be done. And then Geo, I mentioned earlier, they're the challenges. They're at the end, right? I'm sure Pat Simpkins or somebody, or maybe Bulger, has the buck stops here, sign on your desk, because it's all going to come to them. They've got to make it work. And so, but they also are this is kind of what the view from Washington, right? You get the elephants, stamping SLS and Orion and their major contractors around those, and the appropriations process, make sure those are taken care of. GSDO kind of gets in the middle of that, and we have to make sure we can carve out sufficient resources to keep that activity going, because in the end they're going to be on the critical path to get to EM1. But so the challenge and schedule, but making great progress there. Commercial crew, you can see the things we've been wrestling with there. Most of the partners are doing their capsule builds. That's an inherently challenging activity. Parachute testing has been tough, but working through it. Asset load cases, both of these are putting new spacecraft on top of existing launch vehicles, and that's creates some challenges, some engineering design challenges that they're working through. ISS, you're all famously familiar with the cargo resupply challenges. Both of those providers really stepping up and doing the right thing to overcome those challenges, and even to make things happen such that the effects of that are mitigated. I think, for example, of Orbital stepping up and going out and getting Atlas V's so they can meet their contract requirements while they have worked on Antares. Great stuff there. SpaceX similarly really thinking through carefully how to get back to flight and be able to meet our needs and their contract requirements there. Great partnerships with both of those. Asteroid redirect mission, again, this is a Washington thing. The FY17 House Appropriations Bill, not an act yet, but it's a bill, essentially said, no, cease and desist, stop. But it's not a law yet. And we're working to turn the corner on that. Michelle Gates has done a great job advancing the armed mission on all fronts. And she's had meetings with both the House and Senate authorizers in the last month, and made great progress with them, getting them to understand the value of this program to the exploration enterprise. And they, in turn, are starting to ask deep, thoughtful questions in response, which is a good sign to us, because if they didn't care, they wouldn't ask any questions. And so I think there's been a corner turn in understanding the value of that program in the exploration construct. We'll see, what the future holds, but things look promising there. SCAN has been challenged in SGSS, the sustainment ground system activity, and I'm not, I told you earlier, I'm not an engineer. So a lot of things I don't understand. One of the many things I don't understand, because it's not intuitive to me as an observer, is why ground systems are so hard. But they are. You know, in a previous life, I worked in the Earth Observing System program, and the flagship Earth observing satellite, now called Terra, was held up for a year because the ground system wasn't ready. And people like me are just, what is going on here? I don't get it. That's because I'm ignorant, right? There's something inherently challenging about ground systems for these programs, and we see it in JPSS, the weather satellite. We see it for TDRS. We saw it in EOS, and they're seeing it, as I'm told, on the DoD side as well. So there's something inherently challenging about that we don't quite have a handle on. And so at some point there ought to be a forum like this on ground system development and lessons learned specifically. That would be useful to do. And then AES and HRP, again, both making great progress, very well planned out programs with strategies to get to where they're going. But in the appropriations process, they're kind of the remainder in the exploration account, right? So when the other big needs get met, they kind of get what's left over, and they have to bear the brunt of some cuts. Continual challenge for them to replan and make things happen. So again, those are some of the current challenges that we are that we're facing, but we're getting there. And again, I wanted to use these, get these out there, so that you had a broad perspective on the kind of things we need to wrestle with, therefore the kind of things that you need to wrestle with as our community. But what it tells us is that this kind of lessons sharing activity is crucial, right? It's not just a nice thing to do to get away for 2 days at beautiful downtown Huntsville or wherever it is we are. This is really important, right? Your folks being able to share these lessons and figure out how to document them so they're useful going forward is huge, because this is a multi-generational exploration program. And so Ralph said earlier about not just stopping here, but taking what you've discussed here and bring it back to your teams and being able to talk about it, particularly with the rising generation of engineers and scientists and technologists and others in your programs, is really what this activity really needs to be all about. Because it's how we think about these problems over a long period of time, how we think about not just the risk we're taking, but the benefits, as Ralph said earlier, of that risk. And again, this is a chart I stole shamelessly from Mark and Ralph. We need to be able to think about why we're doing what we're doing, what's the benefit of it, what's the cost of it, and think about it in terms of the exploration objectives we're ultimately trying to achieve. And so I hope what I've provided for you this morning is a little bit of larger context of what HEO exploration goals are, so that as you march through these agenda items, and this is a really rich agenda, you'll be able to think about, okay, how does this topic relate to the decisions that this enterprise has to make, not just this year, not just 5 years from now, but over the generational scale in which this exploration enterprise is going to roll forward. So again, thanks for investing the time to be here, and I really appreciate it. I look forward to spending the next day and a half with you. Thanks.